Hello, Nines. I want to talk to you about circle properties a little bit more this morning, and especially dealing with something called a perpendicular bisector. So there's some interesting things that happen when we have a chord and there's a perpendicular bisector to it in a circle. So, but we should first talk about what a perpendicular bisector is, because it is a long term made up of some maybe complex words. So perpendicular is just a really super fancy way of saying 90 degrees, or two lines that meet at 90 degrees. And bisector is the second part of that word. So bi, as you guys know from maybe like binomials or bicycle, relates to the number 2. And so the last part, sect, means to cut. So this part of the word means to cut. So we want to cut a line in 2 equal pieces, and that new line is going to be at 90 degrees to our old line. So if we look at something like this line right here cuts this bottom line in 2 pieces, and it meets that new line at 90 degrees. And you guys are going to often see these 2 tiny little lines. Again, I think I said this in the last video, but I'll say it again because it's worth saying again. That just means that this portion here and this portion here are exactly the same. So those lines are just giving us a clue that 2 pieces are equal. So that you're going to see that come up in your textbook question, so just so you know. The line might go all the way through, and that's okay. This is still a perpendicular bisector. Cuts this line, this horizontal line, into 2 equal pieces at 90 degrees. That is what perpendicular bisector means. So some very funny things happen when we have a chord and perpendicular bisectors in a circle. And let's talk about those right now. So our first key idea is this: the perpendicular bisector of a chord passes through the center of a circle. Wow, I love it. And what that means is that if we have a chord, so you can draw any chord on this circle. I'll just draw one right here. If I draw its perpendicular bisector, which means if I cut this line into 2 equal pieces and I draw its perpendicular bisector, so I'm saying that this piece here equals this piece here, and if I draw a line at 90 degrees to it, that line has to go through the center of the circle. That's what this first point is saying. If we cut this chord, again, if we cut this chord into 2 equal pieces and draw a line at 90 degrees, it has to go through the center of the circle. And so you can always find the center of a circle. If you did this twice, I have the center marked out with a little dot there. But let's say you didn't. If you had to find the center of a circle, all you would have to do is draw a chord, cut it in half, and draw a line at 90 degrees, and just do it again. Cut this line, and the chord could be anywhere, it doesn't really matter. But if we cut it in 2 and draw a line at 90 degrees to it, where these 2 points meet is the center of a circle. So that's going to be really important when you get to your 10.2 assignment for the first question, because you're going to have to do this exact process. So if you don't get that first question on 10.2, I might tell you to go back and watch the first part of this video, because I think it might help. Okay, the second key idea is if a bisector of a chord passes through the center, then the bisector is perpendicular to the chord. So a lot of words happening there. So let's draw it in a visual way to try and check out what's going on here in this second point. Okay, so I have a chord, I know that. And I know this chord is being cut in two, and so there's a line cutting this chord into two equal pieces, and that line also goes through the center of the circle. Since it's in two equal pieces, I'm going to draw those two little lines. So whenever this happens, a line coming from the center of a circle, cutting a chord in half, we always know the angle between this line and this chord. So the line coming from the center of a circle and the line cutting that chord in two at this chord, at this point here, we always know this angle is 90 degrees. That's going to be really, really important because 90 degrees helps us to make, well, it's a right angle. It helps us to make right triangles. And anytime we have right angled or a right triangle, we can solve for missing sides using the Pythagorean theorem. Okay, so that was our second key idea. The last one, the shortest path between the center of a circle and a chord, is a line that is perpendicular to that chord. So all this is saying is if I have this chord here, the shortest line between the center of the circle and this chord is not this, it's not this one, it's not this one. It's going to be the one that cuts this chord in half and that is perpendicular. This will be the shortest distance. I think by my figure it's not exactly perpendicular, but hopefully you get the point. So, how does this apply? We're going to look at a couple example problems. We'll look at 2 example problems, and then you guys will have a chance to try some. Okay, so in this first example, we have a pipe. It has a diameter of 60 centimeters. So let's imagine we got this pipe here, and its diameter is 60 centimeters. The horizontal, we have some water at the bottom. And this water, maybe extends throughout this pipe as well, but I'm just going to leave it like this. So we have this water sitting in the bottom of this pipe. So here's our pipe. We can see the front of it. We have some water sitting at the bottom. We know that this distance down here is 40 centimeters. We also know the pipe has a diameter of, so if I go from one end to the other, going through the center of the circle, I know that this diameter is 60 centimeters. How deep is that water? At this point, I have very little useful information drawn on my diagram. And so in circle geometry, it's very important, and often I have to redraw a diagram, and I'm going to have to add lines so that in a useful way so that I can solve these problems. You will have to modify drawings in circle geometry. It's not all the important lines will not be drawn for you, and you have to, and in many cases, especially in 10.2, we need to modify the diagram such that we can make right angle triangles, because that allows us to solve for missing sides. Because really my question is asking me for this depth right here. So far this diagram is not very helpful. In many of your 10.2 questions, your diagrams as they are right now are not that helpful. I need to change this. I need to change these lines and reposition things so that I can figure out this depth. And I'm also going to use some circle properties as well. The first line I want to draw is a line that's kind of in line with this one here, and that goes through the center of the circle. This black line right here. I'm going to bisect this 40 centimeters down there. I'm going to cut it in two. Couple amazing amazing things happen if I do this. Number one, if I can cut this chord into two pieces, and if it goes through the center of the circle, I know I have a right angle here. I also know the length of that line and that line because it was 40 and I split it into two equal pieces, and 40 divided by 2, punched it into my calculator, and it turned out to be 40 divided by 2 is 20. So I'm gonna put a 20 here and a 20 here. Okay, still not super great. Well, I mean, it's not bad. I think I'm in a better spot now. I also know that this diameter is 60 centimeters across. And if I know the diameter is 60, I also know what the radius is because I can figure out the radius by just taking the diameter and dividing it by 2. So I'm going to do that on my calci. 60 divided by 2 is... It turns out to be 60 divided by 2. What could it possibly be? I got 30. So if this portion here from the center to the edge is 30, so is that one. So I'm going to just erase this for now. I know any distance coming from the center to the, well, I know this. Center to the edge is 30. That's called a radius. Now, here comes the magic. I'm going to draw a line. I'm going to modify the diagram. And when I'm drawing a new radius, I always start at the center of the circle. I'm going to go to this edge right here, because this is also going to be 30. And I'm going to get rid of this one. How does that help me? Well, now I know that's 30, that's 20, and I can find out this distance from the center to at least the top of the water. So I need to use the Pythagorean theorem. I'm going to go a squared plus b squared equals c squared. The c is always the longest side, the hypotenuse, the side opposite from the right angle. So my 30 squared goes here. 20 can go here or here. It don't matter. Plus b squared, 20 squared, 400. Plus b squared, 30 squared is 900. And b squared, I'm going to subtract 400 from both sides to get 500. And then I got to take the square root of 500. So I go grab my best friend, Mr. Calci. Punch that in. I got 22.4. So I know this is 22.4 from here to here. Okay, that still doesn't allow me to find the depth of the water. But I know that this is also a radius. This portion here is 22.4, but if I went from the center all the way to the edge, that's another 30. That's just another radius. So I can find the depth of the water by going 30, take away this 22.4, and I'll get that. Which is going to be 7.6 cms is the depth of my water. Radius CH bisects chord FG. FG measures 12. The radius of the circle measures 10 centimeters. What's the length of CJ? I would, when I get into a question like this, and I got a diagram, what I'm going to do is I'm going to label my diagram as best as I can so that things might pop out at me. So chord FG measures 12. FG, this whole thing, is measuring 12. But I see that it's cut in half, so I'm just going to put a 6 here and a 6 here. The radius of the circle is 10, so from the center to the edge is 10. What is the length of CJ? I think I'm going to use the Pythagorean theorem because I know this chord is being split in two by a line, so I know that's 90 degrees. So I can now use the Pythagorean theorem. So in most of these questions in 10.2, you will have to use the Pythagorean theorem. So here we go. A squared plus B squared equals C squared. C, the longest side right there, has to be 10. One of the legs is 6. B squared, I don't know. Oh dear, that B looks like a 6. Let's change it. This is a B. Okay. And so I have 6 squared is 36 plus B squared. 10 squared is 100. I'm going to subtract 36 from both sides to get 64. Square root both sides, B equals 8. So now I know that this length, CJ, equals 8. And that is really it. Okay, so you guys will have some textbook questions posted soon. And we can talk about these more on class chat as well. Have a great day. Take care.